we need to find the quadratic equation whose roots are alpha, beta, where these two conditions are given to us and alpha and beta are real, right? So these are the conditions for which we need to get a quadratic equation. So how to get a quadratic equation? The format is x square minus sum of the roots into x plus product of the roots equal to 0, right? So for the sum of the roots we are writing alpha plus beta, and for the product of the roots we are writing alpha beta. That is, we need to get this sum and this product, right? Okay. Let's use the second condition first. That is 3 into alpha the power 5 plus beta the power 5 equal to 11 into alpha cube plus beta cube. That implies alpha the power 5 plus beta the power 5 divided by alpha cube plus beta cube equal to 11 divided by 3. Writing the formula for alpha the power 5 plus beta the power 5 as alpha cube plus beta cube into alpha square plus beta square minus alpha square beta square into alpha plus beta. Please note this. So this implies in the numerator we are writing alpha cube plus beta cube into alpha square plus beta square minus alpha square beta square into alpha plus beta for alpha the power 5 plus beta the power 5 divided by alpha cube plus beta cube equal to 11 divided by 3. In the first condition it is given that alpha square plus beta square is equal to 5. So writing this as 5. So this is alpha cube plus beta cube into 5 minus alpha square beta square into alpha plus beta divided by alpha cube plus beta cube equal to 11 divided by 3. Separating the terms, this is 5 minus alpha square beta square into alpha plus beta divided by alpha cube plus beta cube equal to 11 divided by 3. Taking this to the other side, we get 5 minus 11 by 3 equal to alpha square beta square into alpha plus beta divided by alpha cube plus beta cube. Please recall that alpha cube plus beta cube can be written as alpha plus beta into alpha square plus beta square minus alpha beta, right? And the left hand side becomes, this is 4 divided by 3. So these two cancelled out. And again using the first condition, it is given that alpha square plus beta square is equal to 5. So this implies 4 divided by 3 is equal to alpha square beta square divided by 5 minus alpha beta. Cross multiplying, we are getting 20 minus 4 alpha beta is equal to 3 alpha square beta square. So now we are getting the quadratic equation in alpha beta. Right? This 3 alpha square beta square can be written as 3 alpha beta whole square. So this is a quadratic equation in alpha beta. Let's get the roots of this quadratic equation. So alpha beta is equal to -4 plus minus square root of 16. This is plus 240 divided by 6, right? So that is equal to -4 plus minus. Okay, this is square root of 256, that is 16 divided by 6. So that is equal to -10 by 3 or 2. So these are the two roots. Now which root is valid here? Let's check. From the first condition, we are having alpha square plus beta square equal to 5, right? So writing this alpha square plus beta square as alpha plus beta whole square minus twice of alpha beta and is equal to 5. So in the first case, if alpha beta is equal to minus 10 divided by 3, then if I put this value in here, we are getting alpha plus beta whole square plus 20 divided by 3 equal to 5. That is, alpha plus beta whole square is coming out to be equal to a negative value, that is minus 5 by 3. Which cannot be possible, right? Because of the square, the left hand side is positive and it cannot be equal to the negative value, right? So alpha beta equal to minus 10 by 3 is not valid root. Let's check the other one. For alpha beta equal to 2, we are getting then alpha plus beta whole square minus 4 equal to 5. That is, alpha plus beta whole square is equal to 9. And we are getting alpha plus beta equal to plus minus 3. This is the valid result, right? Alpha plus beta equal to plus minus 3. That means we are getting the value for sum of the roots to be plus 3 and also minus 3, right? And the product alpha beta is 2. So the required quadratic equation is x square minus sum of the roots into x plus product of the roots equal to 0. That is, x square minus sum of the roots is plus minus 3x plus product of the roots is 2. So this is equal to 0. Or it can also be written as x square plus minus 3x plus 2 is equal to 0. So this is the required quadratic equation. Thank you.